Hi students, today we will be looking at how to solve quadratic equations. Remember in the previous lessons we talked about quadratic functions, how to write a quadratic functions in a variety of different forms, and then the last lesson that we had was how to factor a quadratic function or a quadratic expression. And we've spoken briefly about this, but one of the reasons why we learn how to factor quadratic expressions is to be able to find the x-intercept, which is going to be the same as finding the zeros now, because finding the zeros means that what the y value is equal to 0, and if the y value is equal to 0, then the x value is really the x-intercept. So finding the zeros is really the same as finding the x-intercept, which is really the same as finding the roots, and that's one of the reasons why we started to learn how to factor quadratic expressions. All right, so let's just go over what it means for a quadratic expression to be a quadratic equation. So first, a polynomial equation is an equation that has a polynomial on one side, and that left side could be like it could be a quadratic expression, but the right side has to be equal to 0, and that's pretty important, or vice versa. All right, so this would be an example of a polynomial equation because it equals to 0. So it has to equal to 0 in order for it to be a polynomial equation. Keep that in mind. Whenever we encounter a polynomial equation, we're interested in a solution because equations will always have solutions. Well, most of the time. Solution to polynomial equations have a variety of different names. Sometimes they're called the roots, sometimes they're called the x-intercept, and lastly, sometimes they're called the zero. So let's take a look at a few ways on how to find the roots, the x-intercept, or the zeros. First, if you are given a polynomial that has already been factored, which is this, then all you have to do is take each of these factors, let's call that the first factor and let's call that the second factor, and set them equal to 0. So we go like this. X minus 5 is the first factor, set that equal to 0, and then solve for x by adding 5 to both sides, and therefore x equals to 5, and that is one of the solution. Okay. We take the second factor, which is x plus 2, set that equal to 0, subtract 2 to both sides, and x equals to 2, and that would be another solution. So in this polynomial, which has already been factored for us, we know that there are two solutions. And the way how we did that was we took each factor and we set it equal to 0, and then we solve. These numbers are the x values that will make the left side 0 if you were to take it and plug it back in for x's. All right, and sometimes you might see these being called the roots or the zeros. All right, because these are the numbers that if you plug them into the polynomial, the y value is 0. All right. Now here is a polynomial that is not in that hasn't been set equal to 0 yet. So in order to solve this polynomial, we start off by setting it equal to 0 by subtracting x and subtracting 30 to both sides. So we go x squared. If I subtract x to the left side, to both sides, then I get negative x, and then negative 30, and then now it's equal to 0 on the right side because we subtract that to both sides. All right, so in order to solve a quadratic equation by factoring, we need to first set it equal to 0, and then since the a coefficient is equal to 1, you can now easily factor this into a pair of binomial, right? By figuring out the two numbers whose product is negative 30. So you take negative 30 and you put on top, and you take negative 1 you put on the bottom. But when they are added together is negative 1. A bit of searching will help us realize that negative 6 and 5 will do the trick. So we insert negative 6 and we insert 5 in there, which means that we have factored this trinomial. And once you have factored it, all you have to do is take each factor, call this the first factor and call that the second factor. Set each one equal to 0. So x minus 6 equals to 0. And if you solve for x, you know that x equals to 6. Take the second factor, which is x plus 5, set that equal to 0. Subtract 5 to both sides. X equals to negative 5. And that is your second solution. And keep in mind that when we're asked to solve, sometimes they might say, hey, find the roots. Because the root also means find the solution. Other times they might say find the x-intercept or find the 0. And whenever they use any one of these words, it means to solve, which means that you have to start off by setting it equal to 0 first. Pretty important, all right? We can also use a graphing calculator to help us solve quadratic equations. Before we can use a graphing calculator, we have to do a few preliminary work to a given problem. For example, when we're given any quadratic equation, the first thing we want to do is we want to set them equal to 0. So we're going to have to subtract 2 and add 2x to both sides to set them equal to 0, which means that we're writing in standard form. Standard form means the equation will be equal to 0. So I'm going to do that. I'm going to go ahead and add 2x to both sides, which is going to give me 32x on the left. And then if I have subtract 2 to both sides, then I get plus 12, and that's equal to 0 now. All right. The next thing I'm going to do is I'm going to use my graphing calculator, and I am going to type the left side into y1. Okay, type into y1. So turn it on, and then go to y1, which y equal, which is right here, and then we're going to type that into y1. So we go 5x squared plus 32x plus 12, and then we're going to hit enter. And the next thing we're going to do is we are going to use the table features to find the zeros. To use the table, we first set up the table by hitting second, window, and then let's start at 0, and then just make sure that under the table equal should be equal to 1. Independent and dependent should be under auto. Once that's all set up, the next thing we do is we go second, graph, and that will get us to our table features. When we are solving for quadratic equations, we are looking for the x values that equals to 0. In other words, we're looking for the x values that makes this function equal to 0. When the function is equal to 0, it's the same as saying the y value is 0, because this is really the y value. All right. Basically, we're going to toggle down until we see a y value that's equal to 0. Notice that as I toggle this direction, the value gets bigger and bigger and bigger and larger and bigger. And more specifically, I'm looking for zeros in the y value. So I know that it cannot be down here, see? So I'm going to go back up. I'm looking for y value equal to 0. So I keep going, and as you can see, as I'm toggling up, these y values getting smaller and smaller and smaller. Now, one interesting thing you might notice is that, and I'll put this calculator up here, is that between the y equal to 0 would be between 0 and -1, because when we go from 0 to -1, I don't know if you can see this, but the y value it went from positive to negative, so somewhere in between there, somewhere in between here, okay, the y value is equal to 0. So I know that one of my answers has to be between 0 and -1. All right, so I know that. And then we'll go back and we'll find that in a few minutes. Now, if you look carefully, when I toggle through the table again, I found another 0, which is at -6. So I know that -6 is one of my answers because -6 is the x-intercept, and the x-intercept is a solution. So that's one of the answers. But I know that the other answer is going to be between 0 and -1. See? Between 0 and -1 because there's a 0 somewhere in the y value. So what I have to do is I have to go back to the table set. So go second, hit second's right here, and then hit window to go back to the table. And then maybe I know that one of my answer is it's near 0 or -1, so I'll change my starting value to 0. And then I'll change my increment to maybe just 0.1 every time. Hit enter. And then go back, go to second graph. And then this allows you to analyze the table in a bit more detailed. All right. Now, as you can see, earlier I know that my answer has to be between 0 and -1, and now I'm just having my table increment each value by just 0.1 units. And as I'm looking through, notice that I have found my second 0, which is at -0.40. That is another x-intercept, and x-intercept are solutions. So guess what? I just found my two solutions using the table. So the two solutions are, use the table features to find the 0. The two solutions are, basically from looking at the table, I found -6, 0, and -0.4, 0. So my answers are x equals to -6. This is one of the roots, or one of the solutions. And then x equals to -0.4. That's another solution. Let me walk you through one last problem using the calculator, but we're going to do it using graphical method. First, we have to rewrite this in standard form. Again, standard form means that the equation must be set equal to 0, so I subtract 15 on both sides. I'm going to go ahead and type the equation into my y1. So once again, you would go y equal, clear what you have there using the button that says clear, and then type in 2x squared plus 7x minus 15. If you need additional time typing in the equation, you're more than welcome to pause the video. Once we have typed the equation in, we're going to go ahead and graph the equation and identify the x-intercept. So I'm going to kind of zoom in on my graphing calculator so that you can see a little better. To graph the equation, you just hit graph. Okay. Now, if you don't see anything on the screen, there's two things you can do to make it visible. Perhaps hit zoom and then 9. And if you hit zoom 9, hopefully by now you should see something on the screen. You should see a graph on the screen. And if you don't see it, try zoom 6. And there it is. Now we are interested in solving, and solving means finding the x-intercept because all these words means the same. So I know that there are two answers. There's one here and there's one there. There's two answers. In order to find those two answers, I need to tell the calculator to find the x-intercept by hitting second, trace. That will take you to a calculate table. And I'm looking for the 0, see? Option 2. The 0 where? Well, I want to look for the 0 there, so I need to kind of move my cursor. The cursor is now at the bottom, so just kind of see how the value is negative 1.6. Well, I need to move the cursor over to negative 1, 2, 3, 4, negative 6. So you keep toggle to the left until the cursor is now up here and it's to the left of the x axis. Hit enter, left bound, yes. And then you need to toggle it so that's below, which is the right bound, yes. And then it says guess the solution, and just hit enter again, you're good. And we hit enter again, then it tells us the solution, and one of them is negative 5, 0. So keep that number in mind because we're going to find the second x-intercept. Do the same thing, second, trace. I'm looking for the 0, choose option 2. And now I need to toggle this over to this other solution. So keep toggling until you see a blinker that shows up. There you go. So to the left, yes, that's to the left, right? To the left of that point. To the right of that point is there. And then just hit enter. Another enter when it says guess. And then it has found a second solution for you, which is 1.5. So we go ahead and we copy those two down. So x equals to negative 5, and then x equals to 1.5. Those are the two solutions that was on the graphing calculator. If you need to rewatch the video, go ahead and do so. I will upload the homework, or look for your homework and complete the homework for section 4.5. I will see you guys tomorrow.